On the tool here, you have all these buttons. You gotta press air to vent your load lock. When your tool beeps and the light is solid, you can open it. So there's a magnet, so hold on to the chamber, one hand on the handle, and then you can open it out. To push your rod out to load your sample, you gotta unlock your rod lock, push this out. Hold your wafer like this if you're gonna load it on here with already the sample holder. There's a clip on the underside of it. When you depress it, it'll move your top clip. So hold it at this angle so that you can put it here. Slide it into all the clips. Make sure that your major flat is parallel to your clip. Up there. Pull your sample all the way back until you get the diode here. Lock your sample. Here's the clip, turns over. Push it into the magnet, press open. This will pump down your load lock and then open the gate. On the software, make sure your specimen size is the correct size here. Otherwise, hit set. Tell it that it's 4 inch. If you have something else that's non-standard height, you compare it to this gauge. If it matches the pin here, then it's standard. If it's lower, then you have to tell it that it's plus or minus however many millimeters. Don't load samples that are outside of this range because you might not make it through the door on the tool. So I have a standard sample 4 inch.
What is this for?
Camera navigation for your sample.
Oh.
I haven't calibrated that, so we'll work on it later. Okay, so the light is solid. We just heard the beep. You unlock your rod. Don't turn this, just push it straight in. If you turn it, you can unlock your sample. So push it all the way in. And notice I'm using the handle here for leverage. Unlock it. Pull it all the way out. Lock it back in place. Press close. While it's closing on the tool, I can go ahead and tell the sample to go home. Check that my accelerating voltage and emission current are what I want. There's this down arrow. I have it set to 1 and 10 microamps. So for EDX, this needs to be at 10 kilovolt and 10 microamps. Tool condition wise, I need to put my probe current to high. That's over here. My condenser lens should be at 2. And my working distance should be 15. So my sample's at home. I'm going to go ahead and turn on my beam. Go ahead and adjust my lighting, and if my working distance is at 15, my sample height have to be the same so that they're on the same focal plane. So I'm going to go ahead and change that to 15. When you change your Z height, make sure you put in the correct number before you hit enter or move, because it could move the stage too high and you might crash into the objective. So make sure you have the correct number and then go move. Then you'll see your sample come into focus. Go ahead and increase your magnification and focus your sample. You find that when you focus your sample, your work distance will change. So when you do that, you have to change your working distance back to 15. And then change your Z height to compensate for that. So this is 14.9. gotta go back to 15, that's 0.1 millimeter. I gotta tell my stage to also go up. I'm just gonna check that I'm still in focus. I can change this just a small amount and my working distance won't change too much. But if I change it by a large amount, it'll really change. For this example, I'm just going to use the lowest magnification that's still in high mag mode. If you go to low mag, you're not going to be able to get a signal on your EDX. So for EDX, you need to go onto the second computer here. It's got its own keyboard and mouse. The program is called Aztec. On the home screen, you can either open an existing project to add on more to it or do a new project. I'm going to hit new project. I'm going to browse, find whatever folder I want. I'm just going to pick Sarah Keith's folder and call this training. Alright. So I need to tell my EDX detector to go in and operate. So I click the collimator down here. Under thermal, click operate. Under position, tell it to move in. If you watch on the IR scope, you can see the collimator moving in. It's that little extra tip right there. So I have the IR scope on. That will give me a lot of signal to my EDX. So I need to turn that off. And once I turn that off, you can see that my dead time moved down into a green range. So you want your input, output, and dead time to be in green. When it's in the yellow, you have too little signal, so you're going to get a lot of noise. When you're in the red, you're oversaturated with signal. You're pretty much going to detect everything, even though it's not there. Okay, so we're pretty much in the yellow, green area. That's good enough. And for this example, I'm going to use point and ID. Point and ID allows me to scan the entire image and select specific area to just scan those areas. So I'm going to move on. You can describe your specimen. This is optional. Go to scan image. So once I scan an image, I do not change my magnification or shift my sample. You can see when the EDX is pulling in the image, it's going to take it away from the SEM. Alright. So at this point, if you move your sample, it's not going to be accurate anymore. Do not move your sample. Alright. Go ahead and go to acquire spectra. And here on the left-hand toolbars, you have different shapes to select from. So I'm going to just select a square, and so I'm going to compare this metal pad to maybe my field area. You can see it's going to label as spectrum 1 and 2. On here I can rename it. When I see that my signal down here is stabilized, that's good enough for a signal. I can tell it to stop. Then it will go on to the next scan. So here's my next scan. It looks like it's stabilized already. I'm just going to go ahead and rename it and then tell it to stop. Alright. Since I finished scanning, I'm going to go to confirm element. So I have first my bond path here and my field area. There are peaks, but none of them are labeled. So I can select my spectrum and tell it to automatically ID all of my peaks. Same with the field area, automatically identify the peaks. Another option on here is you have a compare function. I can tell it plot my bond path spectrum and compare it with the field area. Then you can see the difference in the two, and it will also show me percentage-wise. The weight percent is not atom percent. Weight percent will be heavily biased towards heavier atoms, so this can be misleading, okay? Same with the toolbar here. To save this, you can just go to report result, give it a name, and then this report will generate for you. It will have the selected area where you had selected to do the scan. So whatever rectangle you draw, it will be the average of that entire area. And then it will have your comparison. This is whatever you have on there. And then it will have your whatever you have selected. So on here, I have my bond pad and my field area. Here is plotting my field area and my bond pad. And my comparison line will always be the same. So it's already saved. When you're done, you can go ahead, go to File, save your project, go to your kilometer, tell it to go out, and then put it into standby. I've already saved this. I don't need to wait for the tool to finish going into standby. I can close it out. It'll finish on its own. Remember to move your file into your public folder so you can access it later. I'm going to turn back my iriscope. And I'm done with my SEM, so I can go ahead and just hit exchange. This will go move the sample to the home position, then the exchange position, and also turn off my high voltage.
So I can use low mag or high mag, right?
For EDX, it has to be high mag. If you go to low mag, you'll see on here that it's not going to be able to read enough signal.
Only high mag.
So once it finished going to the exchange position, the light will be solid. The tool will not beep. You have to wait for the light to become solid. Alright, now that the light's solid, I can tell the gate to open because I need to retrieve my sample. Beep, it's open. I unlock my rod, push it all the way in without turning. Because if I turn it to the lock position, I can't push it in. So it has to be in the unlock position. Push it all the way in. The light's on, that means it's all the way in. Lock it. And then pull it all the way out. Lock the rod and press air. This will close the gate and then vent your load lock. The light is solid. I'm going to hold on to the chamber and the handle, pull that out, unlock my rod, push it forward, and I'm going to unload my sample. I'm going to have one hand under so that I can press that clip on this side, and then the other hand I'm just going to pinch this corner here, and there you go, I get my sample out. Can you open for me? So this is training samples. All the training samples are back here. You guys are free to use it. I need to close up my chamber. So you pull this all the way out until you get the light. Lock it in place. Push it to the magnet. Press evac. On your tool, because you used it for EDX and production does not use it for EDX, you need to put it back into production mode. Your probe curve needs to go back to normal. Condenser lens go back to 5. Your accelerating voltage goes back to 1. And that's it.
Thank you.
Okie dokie.